Hello everyone, greetings. Welcome to the session on making use of sealed classes in Java. My name is Venkat Subramaniam. Thank you so much for joining. I'm excited to talk about this new feature in Java. Let's talk about the benefits. We'll talk about some of the ways to write code with it. We'll talk about some of the do's and don'ts, and then we'll wrap it up. Any time you have a question or a comment, you're most welcome to post them. I'll be delighted to listen to what you have to say along the way. So let's get started. Well, let's talk about what these things called sealed classes are in Java. Why bother about them? Well, the first benefit of sealed classes is really domain modeling. I'm a huge fan of software design and being able to write code that actually means what you really intend. Well, one of the characteristics of good design is to write code that reveals its intent. We don't want to really implement features where we kind of slide in something that's not intended because the language doesn't allow it. Well, in fact, that's exactly what the problem was with Java in the past, was we couldn't really model it in a direct way, but thanks to sealed classes, we can do it now. Let's talk about what that really means. Well, there are times when we want to really get control over representing a hierarchy of classes. Well, in object-oriented programming especially, and also in functional programming, we often represent categories of types of data that we often represent. And there are times when we model our classes based on what our domain requires based on the requirements. Well, as we know as Java developers, we can mark a class as an abstract base class. An abstract base class, as we know, can have any number of instances. Its intention is to serve as a base class after all, where we can inherit from it. And of course, you can also create a class as a final class. A final class, as you know, is something you cannot inherit from. It cannot have any subclasses. So notice that there are two ends of the spectrum right here. On one end, you have a class from which can have any number of subclasses. On the other end, you have a class which cannot have any subclasses at all. What about something in between? What if you want to control the classes that you can have as a derived class? How do you do that? Well, the exact point here is that I want to be able to create what's called a closed hierarchy. There are times in modeling, for example, you might be an engineer modeling a particular refinery, and maybe there are certain units that you create on a refinery that are very well defined for a particular operation. Well, from an engineering point of view, those are the only things your application will support. And when you provide a plugin, for example, you don't maybe want a user of your application to throw in something that you didn't expect, because that may throw your application's behavior out of control. So similarly, for example, you could be modeling an application where you are defining some payment methods. Maybe there are certain number of payment methods that you want to really support and not anything else that you want. Or maybe you're a bank and you have accounts that you want to support, and maybe there are checking accounts and savings account or specially defined accounts, and you have business process around them, but you don't want anything that's not already defined or expected. So the question is, how can you really control the hierarchy of classes in your application? This is especially, as I said, really important from the domain modeling point of view, but it's also important from the software behavior point of view. It can reduce the complexity, it can make the code easier to write, you can get even compiler errors if it can be done properly. But unfortunately, in the past, we had to really work with a few hacks to do this. Well, one technique we could do in the past was to define a constructor as a package protected. When obviously if a constructor is package protected, that can be only accessed by classes in the same package. So as a result, you can create a base class with the protected constructor, and the derived classes would be part of the same package. So you control as an author of the class. But as you know, you say, aha, but I can really create classes in the same package. You are absolutely correct. And as a result, there's no real good control over, again, emphasizing that even though that was a mechanism we used. There is one other approach we all have probably tried in the past. Not a very elegant approach for this purpose, but if you're defining enums, for example. If you're defining an enum, as we all know, internally Java treats enums as classes, but ignoring that aspect, an enum gives a nice closed hierarchy, so to say. But enums are really unwieldy to really represent arbitrary classes as abstraction in our system. So this really showed us a missing detail in the language specification, and that's been filled with sealed classes. I know the next statement is such an irony. Sealed reveals intentions, I say. Well, of course, the sealed feature helps to reveal the intention of the code. And of course, that's basically the idea. So when you use the word sealed, you are conveying the essence of what your intention is, that you're creating a closed hierarchy. Let's talk about how that actually works in the case of Java. Well, this is a relatively new feature in Java like I talked about, and you can create a hierarchy of these classes, and there are a few things you need to really be mindful of when it comes to creating it. Let's start with something really simple, and we'll work our way to something a little bit more, general enough, if you will. Let's create a sealed class. Whether it's a class or an interface, you can mark them as sealed. If it's a sealed interface, then you are saying the hierarchy below that interface is closed. If it's a sealed class, then the hierarchy that comes below that class is a sealed hierarchy. So you could use either an interface as a sealed or a class as a sealed, as you will. Let's take a look at an example just to get us going. Well, I'm going to start writing some code here in Java, and we're going to be creating some sealed classes, but let's just warm up really quickly. The compiler is happy with me so far, but I want to start with a sealed interface in our example. So let's go ahead and edit a file called trafficlight.java, as I would like to call it. I'm not going to worry about packages at this moment. We can take care of that later on. But let's create a sealed interface called, let's call it traffic light, if you will. So that sealed interface called traffic light, as we see, interfaces are, of course, for extending or implementing, but making it sealed conveys to the compiler that you want to define a closed hierarchy. In other words, at compile time, you want to clearly say all the possible candidates that can be a subtype of this traffic light. Now, within this file, I'm going to say a final. In this case, we'll create a class, and the class is going to be called as red light, and that implements, in this case, the traffic light, as you can see. So similarly, let's go ahead and create a couple of more in here. We'll create a yellow light, and then let's also create, let's say, a green light as well, are the three things we defined as implementing the interface called the traffic light interface. Well, that's great. We have a trafficlight.java that contains all those things. And if you really wanted to, you could mark it as public. Absolutely not a problem. Now, when I go back to the code, the sample code, and I want to compile it, the compiler is still happy with me. But let's go ahead and create an example of using an instance. We'll say traffic light over here, and here is my traffic light is equal to, let's say, new red light, and I'm able to create an instance of that particular class and use it, not a problem. Well, so far so good. Well, but what did we achieve by doing this? Well, we created a closed hierarchy of the interface in this case. Well, prove it, you say. Absolutely. But notice in this particular case, the three classes that are implementing that interface all reside in the same file. And the fact that you said sealed, the compiler goes looking for all the possible implementations that's been predefined in this particular file. So if I go back over here and try to create a class called, let's say, a broken light, as we see around the neighborhood sometimes, and I'm going to say implements the traffic light as the interface that I want to implement. If I try to compile that code, notice we got an error. But what does the error say? It says class is not allowed to extend the sealed class traffic light. Okay, it says sealed class, but you get the point. It's an interface, but it's a sealed thing, right? It's a sealed class, a sealed interface. But you're not able to really extend from it. And why not, you may ask? Because the closed hierarchy is all defined within one file. That is the simplest behavior of the sealed modifier, if you will. But of course, this is great if the file is relatively small, the classes are relatively small. But what if the class is going to contain quite a number of things in it? you obviously from the design point of view don't want to create a large file that's not going to make any friends for us, isn't it? So you want to really be able to keep the files separate in different classes separate in different files. How do we achieve that? Well, in order to do that, let's get back to this code right here and let's create one more, and we'll call this as a flashing light, which is actually a good use case, isn't it? But I want to create a flashing light like so, but the flashing light, as you can see, is in a separate file. I want that to work. It doesn't work at the moment as we saw a second ago, but let's get back to this code. And right after you define the interface and any extends you want to specify, you can go ahead and specify those. And when you're done with it, you can say permits, and you can provide a list of things that can be implementing that particular interface. So in this case, I say permits, and I can say red light, a yellow light, and then of course a green light. I'm listing them. And then along with it, I put the flashing light as well. Now that I provided the permits right in there, when I come back to execute the code, well, it should actually allow me to execute it. But what's the problem? Aha, one other small detail. Notice we created a flashing light, but that was a genuine mistake. I want to close the hierarchy or convey my intention very explicitly. So in this case, I'm going to mark it as final, saying that I don't want anyone to implement or extend my flashing light class. And now when I run this, the code, the compiler is pretty happy with it. So we created a flashing light in a separate file, whereas we created the red light, the yellow light, and the green light all in the same file where the sealed interface has been provided. So we're seeing a little bit of a difference from the default behavior we saw. You can provide a permits and a list of all the things that would extend or implement that interface, but of course some of those can be in other files. Of course the question is, where could that be in other files? Well, you can use the permits, and when you do, the different implementations of that sealed interface or extents of the classes that are sealed could be in the same module. So they can be in different packages as long as they're part of the same module, as in Java 11 module, if you will. But what if I'm not using modules? What do you do? Well, then they are required to be in the same package if they are part of the unnamed module. As you know, if you don't create modules, then in recent versions of Java, your code all runs in one single unnamed module. Just to illustrate that point, if I go back to this code right here, and if I were to create a package, let's call it as TL is the name of the package I've created right here. And so the package for the traffic light is TL. And I'm going to take away the flashing light from this for just a minute. We'll come back to that a little later. So I've defined this package called a TL right like so. If I go back to the code right now and I remove the flashing light, and of course the traffic light is in a separate package at this point, so let's do an import TL dot, well, star maybe, and you can see that in this case we are bringing in the traffic light from a completely different package, if you will. Now I'm going to go ahead and run this on the command line just to be sure that the compiler is all happy with me and is able to compile the code. Well, let's take a look. It says, please remove or make sure it appears in the correct subdirectory of the module. So it's not too happy with me. So let me go back here and go to the traffic light right here. Let's get rid of this for a second and just work with the interface alone for a second. So we have the traffic light given here, and I'm going to say that this is going to be a permits, and let's say this is going to be a red light, and let's also provide a yellow light, if you will, and let's just start with those two. And I'm going to say a final class here called red light I'm going to create, and I'm going to say this implements the traffic light as we wrote it before. And let's also write our yellow light right here, so there's the yellow light as well. Well, so far so good. We created those two classes. Now I go back to the sample and I'm importing the TL.star, and we bring in the traffic light and the red light. Let's see if the compiler is happy with me. Otherwise, I'm probably making a silly mistake, but we'll take a look and see what it tells us. All right, let's take a duplicate class. It says got it. So let me make sure that I don't have any class files lingering around, and I'm going to blow away the temp classes directory as well. and let's make sure, and let's go ahead and compile this code one more time, and let's try. Well, okay, I'm going to move on from there. I'm definitely making a silly mistake here, and I need to debug that. But anyway, you get the point. So essentially, the idea behind this is if it's an unnamed module, well, all the implementing classes must be in a same package. That's a requirement. Of course, if you're creating modules, you have a little bit more leeway where you can actually put them in separate packages, but as long as all of them belong to the same module. Well, given this, of course, some of the things we should think about is, what are some of the restrictions? Well, when I say the word restriction, there's actually good things to really protect us to make our lives a lot better. What are some of those things available? Well, first of all, we need to directly extend or implement, if it's an interface, from a sealed class or an interface respectively. So if you want to create a closed hierarchy, you need to start implementing those classes or interfaces. For example, let's go back to the code that we wrote a few minutes ago, and let's go ahead and say we have a sealed interface that we created. Let's not worry about the permits right now. Let's just define the interface alone for a second without the sealed. So when I write the interface like so, if I go back to the compiler and ask the compiler to simply go ahead and execute the code, you can see that it's still, okay. It's pretty happy with it. However, if I go back here and say sealed right now, and we define the interface as sealed, and I go back and try to compile the code, well, the compiler didn't complain at this point. But what if I were to create this as a class, let's say in this case, a sealed class as a traffic light? I'm going to define it as a class, and I'm going to see what the compiler wants to tell me. So in this case, of course, when you're defining those things separately, what's going to happen though is it's going to complain eventually that you are using something that's sealed, but you don't have any classes inheriting from it. So for example, notice sealed classes, of course, in this case, it gives me an error and says sealed class must have a subclass, it says. Well, obviously in this case, I can't just mark it as sealed and walk away. What if I said a sealed interface, if you will? Let's go back and compile the code one more time, and again it says sealed class must have a subclass. So the compiler, as you can see, is beginning to protect us right there and tells us that, hey, you really need to have subclasses for it, otherwise what's the point of writing it as a sealed? After all, it's a closed hierarchy. And what good is an interface which never has a subclass? I know we have done that sometimes in building frameworks, but it doesn't make sense to make it sealed because it's got to be a closed hierarchy. So obviously here, I'm going to go ahead and say final class. And in this case, we're going to say, let's say a red light as the implementation. We say implements, and in this case, we say traffic light, and the compiler is quite happy with us right now. And the reason, of course, is because we are creating a class to implement that particular interface, and the compiler is quite okay with it. Well, a few other things to consider. You need to really extend, as I said, or implement that particular sealed class or an interface. But what can you mark when you create a hierarchy? Well, here's the problem. When you create a class like a yellow light, for example, now in this case, if I say implements a traffic light, well, this could be a genuine mistake I make as a programmer where I made the interface as sealed. And so, of course, no one can inherit from a red light because I made it final. But on the other hand, what about yellow light? Well, somebody could extend from yellow light, and as a result, there are multiple classes now that follows the traffic light interface. Well, what that means is this is, after all, not closed. But that is merely accidental. I didn't mean it as a programmer. Well, the compiler says, hey, wake up programmer, you did not really close this inheritance hierarchy, and that's exactly the error that it's going to give us right now. So if I go back to compile the code, notice the error says that you have an error, you need a sealed, non-sealed, or final modifier is expected, and it complains in the definition of the yellow light. So in other words, it says, hey, you better mark this as final, it tells us. So by marking it as a final, you can see the compiler is quite happy right now. And that's because you promised no one can extend from yellow light. And as a result, this hierarchy is closed. And that's a good thing. Or you say sealed right there. Well, what if I mark it as a sealed in the case of a yellow light? Well, that kind of makes you wonder. You have a class that is sealed. Where is something that inherits from it? So notice it says sealed classes must have a subclass after all. So in this case, clearly, I might come back and say final at this point, and I can say class, maybe yellow, special, maybe yellow light, or typically in my neighborhood, we have flashing yellow lights, and maybe that's something you want to define where you can just be going with caution rather than having to stop. So in this case, I'm going to say extends yellow light as an example. Well, now, of course, when I go back and compile the code, you can see the compiler is not unhappy with me. There are no errors at this point. So you can see how we marked it as a final in the first place, or you can mark it as a sealed. Well, one other option you saw it allude to is you can define it as a non-sealed as well. Well, this is by intention. You are saying, no, I don't want this to be a closed hierarchy at this point. I want to open this up. So that is clearly saying, it's kind of like an override button that you press and tell the compiler, hey, I know what I'm doing here. This is not accidental. This is intentional. I want to open up the hierarchy again. I don't want to close it. And that's a non-sealed option you could use. And I'm hoping that you wouldn't do that too often, but the compiler gives you that flexibility if and when you feel like you really need that. So we talked about this concept of sealed interfaces and sealed classes. Just to reiterate, you can mark an interface or a class as sealed. Of course, if you do, you absolutely have to provide a subclass immediately within your module or within the same file, whichever you choose, or within the same package. Well, you can use permits if you want to provide a list of all the candidates. Of course, you may say, hey, can I use a star? Programmers have asked me sometime, can I use a wildcard? Well, the answer is no, because you really want to control and define your closed hierarchy. You want to be really specific about it. And of course, if you think about what if I have a large number of classes, well, that's a problem in itself from the modeling point of view. So that may not be a good candidate in this particular case. Well, of course, you can use a permits, or you can just put them all in the same file. If you do use permits, it gives you a little bit more flexibility to put this in multiple files. If without modules, they got to be in the same package still. With modules, it could be in separate packages, but they could be in the same one single module. Now, obviously, in this case, we also saw what you can put in the derived classes. It's got to be marked as sealed or final or a non-sealed. You can't obviously mix them all together, but you can use one or the other, but you're required to use any one of those three in the classes that extend from a sealed class or implement a sealed interface. Let's revisit what we talked about with some of the benefits we're going to see in this particular approach. Well, the very first benefit is better modeling. And that is one of the benefits you're going to see is that you are able to represent with intention what you are trying to convey from your object modeling. Like I mentioned, depending on your domain, whether in an engineering domain or a banking domain, or you are in a processing of order, it doesn't really matter. You can bring in your domain knowledge and bring in your domain-driven development concepts and say, I want to really create this closed hierarchy. And now the compiler gives you a way to really provide that. So it becomes easy to read the code and understand the intention. And I'm a big fan, I'm sure you are as well, about how you can really make the code very intentional. earlier in the past, you made the constructors, package protected. You never really said what you are intending. It kind of worked, and we can give pattern names for it. But why give pattern names when we can actually have a very natural feature in the language? So it feels like we are doing more mature development because the language is more mature to provide those capabilities on our hands, and that is something we can be really appreciative of when it comes to better modeling. But not only that, the compiler is able to provide us better checks. We saw this already in a couple of different situations. You saw how I was getting compilation error when I created a hierarchy, but I tried to create a class that was not part of the hierarchy. And so it said, you can't create this class because you are not a member of this closed hierarchy, so it does not allow us to sneak in those classes. Of course, the benefit of this is when you're working with an algorithm where you want to take an action based on a particular type of the object, you're not going to have something sneak in and appear on you as surprise, and then you get an unhandled exception in your code or something goes haywire. So you're able to really push this to the compiler check and be very preemptive. I think we can be really appreciative of that because if a compiler can, don't get me wrong, I'm a huge fan of writing automated tests, and anytime I'm writing these kinds of things in my code, I always want to write a test for those things. But as much as I'm a big believer in automated testing and unit testing, I will never tell you that I will not take a compiler's help. If a compiler can give me that error, that's a first line of defense, that's awesome. And that's what we really get out of this is a compiler keeping an eye over the hierarchy, and anytime we deviate from it, it immediately gives you an error. So it prevents us from entering into a situation where a piece of code may be having to handle something that it did not expect when it is dealing with subclasses of a hierarchy. Well, not only that, this also leads to one beautiful benefit of pattern matching. Well, we have to wait a little longer to see that benefit, but it's really a beautiful benefit where in pattern matching, your compiler can verify you handled all the possible scenarios. In order to illustrate this, I'll give you a tangential example, but I hope that this actually gives you a feel for what this will be in the future when this becomes available. So for example, if I were to define an enum, let's say, and in this case, I define A, B, and C as maybe possible values that I want to define for this particular enum in this particular case. Well, if I were to define an enum, for example, of some values I want to define, you want to be able to say that the values that you want to really bring in are going to be within this hierarchy. So if you were to say, put a switch, for example, in this case and say that I want to really create maybe a switch statement that's going to receive objects of different types, if you will. So for example, let's say state is going to be some values that you want to define within your hierarchy of a state. You can specify what those values maybe must be, and you can dictate what those possible values could be, for example. So if I were to have a switch, let's say a public static, let's say void process, and the process is going to take, let's say, an object of state, and let's say state over here, and within this, let's go ahead and return a string, if you will, as a response from here for a process. So what I want to do here is to say a switch expression, and I want you to think about this in terms of how a sealed class hierarchy will play nicely with this kind of scenario. So we will say a state over here, and maybe in this particular state, I want to say that this is going to be, let's say, a case of A, and I'm going to say, got A, for example, I want to return that. And similarly, I want to return for maybe a B or a C, and I could say this is going to be a B or a C, a very trivial example, as you can see in this particular case. Now, if I were to go back to this code and don't provide the option C, notice the compiler was able to tell us that we are not really covering all possible options. Well, that's exactly the point. A very similar behavior you can expect in the future about how you are dealing with maybe a sealed hierarchy. So if you're a pattern matching expression doesn't handle a particular hierarchy, you will get an error right away, and either you have to bring in, noticing that error, maybe that option you have not considered, if you will, for example, or you will have to throw in a default in this particular case, as you would expect, as the case may be. So for example, default, and I could say something else, for example, and you may potentially handle that scenario as well. So imagine in the future we'll be able to really use a nice little pattern matching and get the feedback that all possible options are being handled, or if it is not. So that way you're got covered on both ends. One, if a surprise type sneaks in, the compiler stops from that sneaking in. And if in your code you're not being exhaustive, the compiler immediately gives you a error as well to say, hey, you need to really go back and address that. That minimizes the error in the code quite substantially, as you can see. So not only is this a better from the modeling point of view, but it's also awesome from the point of view of getting really early errors as well. And that's one of the reasons I'm really excited about this, and I hope you are as well.